They say a picture is worth 1,000 words. Meet M13, also designated NGC 6205, the Great Hercules globular cluster of stars. In this image, you can see hundreds of thousands of stars bound together by the gravitational force. Globular clusters can be found throughout our galaxy, and unlike open clusters of stars, these are ancient structures of massive stars that are bound together through gravity, and they have had enough time to arrange themselves in these magnificent spherical structures. The reason I chose M13 is that any one of you in a clear night sky can actually see it as a faint dot with your naked eyes. In fact, the Great Hercules globular cluster of stars has an apparent magnitude of 5.8. It's interesting to know that based on observational astronomy, the distance of this great cluster is 22,180 light years from us. What it means is that when you're looking at it, you are not seeing it as it appears today, but you are observing it as it appeared 22,000 years ago. This great structure has a radius of 72.5 light years, and its estimated age, is 11.6 billion years. That means this cluster formed long before the Earth formed, long before the solar system formed, long before the sun was there. In fact, this globular cluster is, I would say, roughly the same age as our own Milky Way galaxy. From a physicist's perspective, I can tell you that when I look into this picture, which, by the way, you can find thousands of images of this globular cluster on the internet. When I look into it, what I see is Newton's universal law of gravitation. Have you ever asked yourselves why we think of gravity as a universal law? In fact, the gravitational interaction is one of the 4 fundamental forces of nature. And it was through the work of Sir Isaac Newton that gave us a simple mathematical structure of gravity. In fact, When I look into this picture, when I observe the spherical symmetry of 300,000 stars forming this great pattern, this great geometrical sphere in the night sky, I realize that the force of gravity must only depend on distance. This was what Newton taught us. Not only it depends on distance, it depends on distance in a special way. We all know from elementary mechanics that the gravitational force, the force that keeps us on Earth, the force that keeps the moon in orbit around Earth, and the force that keeps the planets in orbit around the sun, it varies as the inverse square of distance between objects. If you look at the central region of the globular cluster, you would see that it is intense in brightness. This indicates that the number of stars as you get closer to the central region increases. And as you move farther or further away from the distance, it decreases. And the way it decreases can be modeled to be exactly in accordance to the inverse square law of force. This force of gravity is there throughout the cosmos, not only from our neighborhood, but throughout the entire universe. That's why we call it the universal law of gravity. Globular clusters often contain many number of stars, ranging from tens of thousands up to hundreds of thousands. And it's estimated that M13 contains roughly 300,000 stars. Now, with our greatest and most powerful space telescopes, and even the great powerful telescopes here on ground, we cannot distinguish all of the stars in this cluster. The reason, obviously, is due to the distance between the structure of stars and Earth and the limited capability of our ground-based and space-based telescopes in resolving individual stars that are close together. It is somehow impossible to count each individual star, to tell each separate star apart. That's why this image looks like a blob that has been smeared out. But look at it, look at its beauty. Look how the inverse square law of Sir Isaac Newton is actually in play here. In fact, it is probably Newton that he used his own handmade telescope, which he designed as a toy, to look into this system and realize that his law of gravity not only applies to objects close to us, but to distant objects as well. Of course, our cosmos is incredibly large in scale, and the Hercules globular cluster is considered a close neighbor to us on the cosmic scale. But when you look into these great families of stars within our own galaxy, you would find countless numbers of them scattered throughout the night sky. Now, as I said, unlike open clusters such as the Pleiades and the Hyades that don't have a regular shape, globular clusters, due to their age, due to their enough amount of time that they had in forming, they eventually make up these beautiful cosmic grand spheres. Physics is poetic. Usually, people get lost in the mathematics, in the technical details when working out the rules and the laws of physics. But every once in a while, we should step back and admire and appreciate the glory and the significance and the beauty of the phenomenon that we see in nature. And we should be proud of ourselves because on a very little planet in a corner of not a significant galaxy, our species, our fellow human beings, the greatest minds that have walked on this earth, the greatest scientists, have been able to teach us and to explain to us the mysteries of nature. It is often said that the most incomprehensible thing about the world, the universe, is that it is comprehensible. We can comprehend, we can understand through mathematics the workings of nature. This is attributed to Einstein. And, next time when you look at M13, pause a little bit and think and be curious and appreciate this great structure of stars in our neighborhood. Anyway, I hope you've enjoyed this video. Remember, always be curious. And as Einstein put it, the day you start dying is the day you stop learning. Until next time, take care of yourselves and bye-bye.